Welcome to The Explainer. We're going to get right into it today because there's a huge shift happening in automotive engineering. We're talking about how ASPICE is transforming from just another box to check for compliance into the absolute backbone for survival in the age of the software-defined vehicle.
So, here's our game plan. First, we'll look at the perfect storm brewing with new regulations. Then, we'll talk about seriously upgrading our engineering toolbox. After that, we'll get into building an integrated compliance backbone, and of course, how to govern our new AI copilots. We'll wrap it all up with a clear strategic roadmap you can actually use. Okay, let's dive in.
All right, let's set the stage. The world of automotive compliance has been completely turned on its head. It's this convergence of relentless new regulations, the complexity of software-defined architectures, and now AI all hitting us at the same time. It's putting an incredible amount of pressure on every single engineering team out there.
To really understand what's at stake, let's start with a real-world story that should get everyone's attention.
This is not some what-if scenario. We're talking about the Porsche Macan, a massive bestseller. It was literally pulled from the EU market. Why? Because its underlying electronic architecture was too old to meet the strict new cybersecurity regulations without a prohibitively expensive overhaul. This is proof positive that non-compliance isn't a paperwork problem anymore. It's a revenue problem.
And the pressure is just relentless. UNR 155 became mandatory for all new vehicle registrations in the EU in July 2024. That's happening right now. And right behind it, the EU Cyber Resilience Act, or CRA, starts kicking in. These deadlines aren't years away anymore. They are here.
Okay, so in this pressure cooker environment, how do we possibly respond? Well, the first, most critical move is a radical upgrade to our engineering validation technology. We have to get smarter tools. To meet the kind of assurance levels that auditors demand for standards like ISO 21434, the old black box methods just don't cut it. Where you're just throwing inputs at a system to see if it breaks. We have to move beyond that to a much more intelligent white box approach. We're talking about instrumented fuzz testing.
And when you put these two approaches side by side, it's really no contest. Traditional black box fuzzing is like scratching the surface. You'll find some easy-to-find crashes, sure. But instrumented fuzzing? That's like having X-ray vision. You get precise code coverage metrics, it scales beautifully in a virtual environment, and it finds those nasty, deep logical flaws. Most importantly, it generates the deterministic, repeatable evidence that auditors require.
The real magic here is integrating this technique directly into your CI/CD pipeline. You shift left. You're finding those critical bugs, things like memory overflows, at the unit testing and integration stages, not weeks or months later. The result? You discover and fix these huge issues when they are exponentially cheaper to fix, often cutting your costs by more than 50%. It's a total game changer.
So once you have the right tools, you need a solid framework to use them in. Let's zoom out and look at the process architecture. How do you build this all into a single, resilient, integrated system? The biggest trap that teams fall into is creating separate, redundant processes for every single new regulation. It becomes a bureaucratic nightmare. The strategy has to be building a single source of truth, a unified governance framework we call a product cybersecurity management system. This integrates everything.
And if you need a reason why this integration is absolutely non-negotiable, just look at the EU's Cyber Resilience Act. The timelines it demands for incident reporting are so extreme, they make those traditional siloed processes completely impossible to manage.
Now here is the crucial insight that can save you a ton of rework. You don't need to invent a brand new process. You already have a great foundation in ASPICE UP9 for problem resolution. The key is to extend it. You just adapt it to classify cybersecurity vulnerabilities and incidents, perform the right root cause analysis, and then trigger automated reporting to the authorities. That's how you meet the CRA's demanding 24-hour and 72-hour windows.
And the CRA also extends our responsibility way past the point of sale. We are now on the hook for a minimum of 5 years of cybersecurity support. Think about that. That forces us to manage software bills of materials, or SPO buns, and deal with vulnerabilities long after a car is driven off the lot. Okay, and finally, we have to talk about the new elephant in the room, AI. How do we integrate generative AI into our development lifecycle as a powerful copilot without it completely torpedoing our compliance efforts?
So here is the core conflict. ASPICE audits are all about deterministic evidence. It has to be reproduced, controlled, and stable. If you run the process again, you have to get the same result. But generative AIs are stochastic. They're variable by design. Their output is not meant to be perfectly repeatable. For an auditor, that stochastic evidence is simply not acceptable as formal proof.
This leads to a fundamental cultural shift that we all have to make. Think of AI as an incredibly powerful co-pilot. It's there to help, but the human engineer remains the pilot in command, 100% accountable for the final result. We have to stay vigilant about AI's limitations. It can hallucinate, meaning it can just invent requirements out of thin air. A tiny error it makes early on can cascade into a massive system failure down the line. It just doesn't have the deep intuitive context of a seasoned engineer. And ultimately, there's a huge accountability gap. The standards require a named human to be responsible, and an AI just can't be that.
Okay, so what does all this mean for you when you get back to your desk? Let's distill this down into a clear, 4-step strategic roadmap that you can put into action.
Here are your 4 key actions. 1. Deploy instrumented fuzzing deep inside your CI/CD pipeline. 2. Upgrade your existing SUP9 process to handle those CRA reporting deadlines. 3. Establish a bulletproof chain of custody for everything AI generates. And 4. Build that integrated PCMS to stop drowning in paperwork. These 4 moves work together to create a truly resilient engineering practice.
So I'll leave you with this final thought. In this new era, the quality of your engineering process isn't just about compliance anymore. It's now either a fundamental competitive advantage that drives you forward, or it's a critical business liability just waiting to happen. Which one is yours?